Hello. Remember Mat181 trig 7.3 discuss law of cosines. Do you remember this problem from last time? We had to figure out the area of this. We saw there were some formulas, picked the correct one, and did it. So what I did is a little blow up of this problem. I said, well, what if we wanted to find, instead of the area, we wanted to find side B? Well, we know B is the sine of B, as A is the sine of A. And that would mean that B, well, we don't know, is to the sine of 56, as A, which we do know, 34, is to the sine of B, or sine of A, I should say. But the problem with this is we don't know the sine of A. We don't know B. And there's no way we can find this. To do the law of sines, we need two angles and one side. You see, here we have two sides and one angle. So we can't really solve this problem. But fear not, we have another law called the law of cosines. So the law of cosines consists of three different little formulas. I would say we're looking for B. B squared equals, as long as we know to use the law of cosines, we need two sides and the angle between them. This will work perfect. So we got B squared equals A squared plus C squared. Okay, the two things we aren't using. Minus 2, and then AC. And then finally, the cosine of B. We do need the side opposite that angle. We need the angle opposite the side. So this is the law of cosine. We also have another one. Let me put them all down here. A squared equals B squared plus C squared. See the other two. Kind of like the Pythagorean theorem. Minus 2 and then the BC. And then the cosine of whatever you start out with, A. Angle A. Or we could have C squared. C squared is B squared plus A squared, or you could switch them. Minus 2 BA cosine C. So these are the three laws of cosine. They're on page 307 of your book, or they're on the back cover, or they're in one of those sheets I gave you. So this is kind of how it works. So let's try this. Let's move this one out of the way. And let's see if we can find this information out. Let me put something here so it doesn't bleed through. So let's take our picture here, our drawing. Let me redo it. Just kind of quick so you can see it. This was 56 degrees. This is B. I just kind of rounded it. This is 42. This is side C. This is side A, 34 feet. And this is B. That's what we're trying to find. So let's start with our formula. B squared equals A squared plus C squared minus 2AC times cosine of B. And let's substitute in. A is what? 34 squared plus C is 42 squared. So it's a little bit more complicated formula than what we were using. Minus 2 times 34 times 42 times the cosine of B, which was 56 degrees. So this would be our formula. So let's dig in and see if we can solve it. B squared. Obviously, you need a calculator on this one. Square it out. Where's the best place to put this? I think you can see it pretty good there. Okay, 34 squared. I don't know if we can do this whole thing at once, but we could give it a shot. Let's take a look. 34 squared plus 42 squared. You can hit our square root buttons. Minus 2 times 34 times 42 times cosine 56. And make sure this is set to degrees. Equals. Seems kind of big. Seems like we didn't do it. Oh, you know what I did? Okay, that's okay. But that's b squared. What we are looking for is b. So now we have to take the square root of that. And I just carried out a couple of decimal places. So second x squared, wrong one. Let's try it again. Second x squared, 1322.94 equals 36.37. Well, let's just round it off to a whole number, 36 feet. And then we got our answer. So don't forget, when you get through, we got to take the square root of both sides. And of course, this is plus or minus, but we want a positive answer. You know, can't have negative answer. So that's basically the law of cosines. Pretty nifty little goodie. So let's try another one here. It's out of the way. Throw something down here. Okay. Let's try this one. On page 308, there's this lake. Okay. And it says a surveyor wants to find a distance between 2 points on opposite sides of the lake. Maybe he's trying to find the distance of this lake. And these points are A and B. And then he wants to, we're standing at point C, point out here. She measures this out and she finds that this distance, B, well, let's label these first. Let's draw a little triangle. This would be distance B, because it's opposite. This would be distance A, and this is distance C. So she finds that B is 259 meters, and A is 423 meters. And ABC, ACB, this angle right here, or angle C, is 132 degrees, 40 minutes. That's this angle right there. So what she wants to do is figure out what the distance is between A and B, which is side C. So just having looked at this formula might be a little hard to remember, but C squared is equal to A squared plus B squared. Now, was it plus or minus? Minus 2AB cosine of this little small c, capital C. So it's A squared, B squared minus 2AB cosine C. And the reason we can't use law of sines on this one is because we only have one angle. We need two angles, and there's no way, we don't know this is a right angle, so you can't subtract from 180 or 90 or anything like that. So c squared equals a squared, which is what? A squared is right here, 423 squared, kind of a big number, plus b squared, 259 squared, minus 2 times 423 times 259 times, I'm going to put it down here, the cosine of 132 degrees, 40 minutes. So we got our work cut out for us. Let's put it in. And, you could start off by hitting second x squared right away and take the square root, but I think it's a little bit easier just to calculate this and then take the square root at the end because we want c. But right now we're going to find c squared. So this is 423 squared. So I just hit the squared key. Plus 259 squared. 259 squared minus 2 times a, 423, plus, times b, 259. These could be in either order, times the cosine of 132, go to the key right here, degrees, and 40 minutes, 40, go to this key right here, slide over, hit the equal sign, minutes, parentheses. So you can use the whole thing, equals. Okay, large number again. Remember, we're going to take the square root of this. 4510.5693. We'll put the whole thing in. So c squared, the whole thing. Second, x squared, 394510.5693. Parentheses equals 628 feet, 0.1 feet. And what did they come up with? Hopefully they came up with the same answer they did. So that's all there is to it, huh? Just a matter of plugging into the formula. So that's pretty good. This one might be a little bit harder. Let's try this one. Got to try and it looks sort of like this. This is a 42.3, and this is angle B and C. So this is side B, this is side A, side C, and see, B is a 12.9, and C is 154, 15.4. These are in meters. Okay, this was meters actually. All right, so let's see what we can kind of do on this one. What do they want to find? In this figure, it says solve the triangle, whatever that means. Okay, so I guess they want us to find all the sides and all the angles. Okay, so let's try to find angle A, side A first. Then we'd have all the sides. So A squared equals B squared plus C squared minus 2 BC cosine A. A squared equals B squared, 12.9 squared plus 15.4 squared minus 2 times 12.9 times 15.4 times the cosine of 42.3 degrees. So let's go ahead and calculate how this mess out. 12.9, I'm just going to use this. This one was 15.4 minus 2 times. Let's go back here. Minus 2 times 12.9 times, I guess I have to change it. 15.4 times cosine 42.3. Cosine 42.3 and parentheses and get rid of it. Okay, so we don't have to put degrees on this because it's automatically in degrees. Something good, because I came up with a negative number, I should have just put it in correctly. I was trying to use the other one. Try it again. $15.4. 42.3. 109.69, but remember again, that's a squared. So a is going to be the square root of that. 109.7 was gone. $10.47, 10.5 we call it. 10.5 meters. The book came up with 10.47. So pretty close, 10.5, close enough. So now we want to find, we've got this side, right? 10.5, but we want to find these angles. So let's find angle C. So here's where we're going to use the law of sines. C is to the sine of C as, let's use B. We're looking for angle B. Well, we have to use actually A. A is to the sine of A. So what do we know on this thing? We know C, 15.4 sine C equals A. We know A, we just figured it out, 10.5. And that would be to the sine of A, which is 42.3. Same. So now we can calculate, and sine C is going to equal what? It's going to equal 15.4 times sine 42.3 divided by 10.5. So Chris, multiply diagonally and divide by the number that's left. Let me say that again. Multiply diagonally, divide by the number that's left. All right. 0.9871. Okay, but that's the sine of C. I want to know what angle C is. So angle C is the inverse sine of 0.9871, because I'm looking for an angle here. Okay, so I have to hit second sine 0.9871 parentheses equals 80.78 or 80.8 is what I come up with. And I might be off a little bit because I rounded this off. So angle C, they said it was 81.7. It might be because I didn't use 10.47. I used 10.5. Now at this point, 80.8, and maybe I made a little mistake, but I don't want to go back. So now I can add these two angles and subtract from 180 and find the other thing. So angle C is just simply 180 minus 42.3 plus 80.8. So that makes it kind of fun to do. 180 minus 42.3, back this up. I should have put this in the parentheses. Let's clear this out. 180 minus parentheses 42.3 plus 80.8 I had. Of course, this will be off in the book because I'm using a different value, 56.9. And again, it could be on my rounding, they got 56.0. So, you know, off a little bit. Maybe I could have made this 81 and this would have been closer to 57, who knows. But anyhow, this is kind of how we should do it. So we can find our angles. This was an angle C, by the way. This was angle I had angle C. This was angle B, excuse me. Got messed up here. This should be 80.8. And now I found angle B. Sorry about that. Yeah, that would be angle. This was angle C that we had solved. So, you know, I kind of rushed it and kind of made, and that's the problem when you do a rush job. Sometimes you mess up. So you kind of get the idea. Sometimes you have all the sides and you don't have the angle. And so I want to show you a little something here. Sometimes we have to rewrite the formula. Sometimes we have the formula, but it's not exactly what we want. So let's say we had this formula right here. We have all the sides. Say we're trying to find C. Okay, so we have this, but we're actually looking for the cosine of C. There's two ways you can do it. You can put in all your numbers, but then the problem with that is, you know, it gets a little messy. So what you can do is rewrite the formula, but I'm going to show you a quick way to do it so you don't get all involved. What I'm going to do is bring the C squared over to this side, and I'm going to bring the negative 2AB to the other side. I'm going to switch sides with just this portion of the problem. So let's bring this over first. This will become positive 2AB cosine C equals, and this will be A squared plus B squared minus C squared. If you do it this way, then you don't get bogged down with negative signs so much. Bring this over, it becomes a negative. Bring this over, it was negative, becomes positive. Now I want to find for cosine C, so I'm going to divide both sides by 2AB. So we have a new formula here. Cosine C, we're trying to find that angle, is equal to A squared plus B squared minus C squared over 2AB. So let's see what information they gave us on this one. They gave us that A is 9.47. So we got to square that. B is 15.9 squared. And C was minus C, 21.1. squared over 2 times A, 9.47, I believe, and times B, 15.9. And that's going to give me the cosine of C. So what I might do on this particular one is calculate the top, then calculate the bottom, then divide. So I'm going to try it that way. 9.47 squared. Let me put it over here so you can see. 9.47 squared plus 15.9 squared plus 21.1 squared. So the top came out to 787.7009. Now I'm going to do the bottom, clear this out, 2 times 9.47 times 15.9 equals 301.146. Now if I divide both of those, I should find the cosine of C. 787.7009 divided by 301.146 equals. Seems off. Something's wrong. Because this should come out a value that's smaller than 2. I see. I think I see my mistake. 787.7009. No. Let me multiply the bottom again. Let's go back up here. 2 times 9.46, 7 times 15.9. Okay, let's go back up. 787, 9.47 squared plus 15.9 squared minus, here's my mistake right here. Minus 21.1 squared. Way off. Negative 102.7191. The sine and the cosine have to be a number that's smaller than 1. So now the cosine of C is, this was a negative, so I'm going to save a little bit of work and use their figures when I do. I want to make sure. Let's make sure. We're going to divide this by 301.146. I get a negative 30.34109021 if I want to get, super accurate. Okay, now I want to find C. That's not the angle. I'm looking for the angle. So I have to hit second cosine, arc cosine, negative 0.34109021. Second cosine, negative, sorry, I'm kind of all over the place with this little calculator. Let's move this up. 0.34109021. Lots of manipulation. It's just, that's all you're really doing. And I come up with 109.9. So that's what the angle is equal to. So when you first do this, make sure this is the cosine of that, but you want to find the actual angle. So you can call this inverse cosine or arc cosine. And that means when you see that word arc cosine or inverse cosine, you have to hit your second cosine key like that. Okay. So I think we kind of got the idea behind it. Then if we want to find something else, we usually, jump over to law of sides or whatever we can do. It saves a little bit of work. Okay, I'm going to give you another thing here. Remember last time, I've got it here, I gotta get rid of it. But we started off this lesson and I showed you that we found the area. Well, another way to find the area is using a little thing called Huron's formula. This was developed by a king a long time ago. Sometimes they call it Hero's formula. It says it's named after the Greek mathematician Huron of Alexandria, lived about 75 years. He was a king, and he came up with this formula. And it was developed because a lot of times we have a triangle. And I'm going to keep it kind of simple. Let's try to make this simple so it isn't so, huge. They made a huge problem out of this. I don't want such a big problem. So let's make sure, let's take the 3, 4, 5 triangle, but it doesn't have to be a right triangle. We just say these sides are 3, 4, 5, just to make it simple. And here I wanted to find out what the area of this triangle is. But the problem with this is, we don't have the height. Remember, the area of a triangle equals base times height divided by 2. But, if it was a right triangle, we could probably calculate the height pretty easily. But if it's not a right triangle, it's hard to do. So, and this will work for any triangle. So what he said is the first thing we're going to do is we're going to take the sides and add them together. And then we're going to divide that by 2. And this is what he called S. So 3 plus 4 is 7. 7 plus 5 is 12. 12 divided by 2 is 6. So S is 6. Then he wrote a little formula using this S. It's going to be S times S minus your A, S minus the other angle, the B, S minus side C. So it's S times S minus side A, side B, side C. Okay, we'll just call this A. We'll call this B. We'll call this C, just to make it easy. So first we got to put in, and then the square root of that. 6 times 6 minus 3, 6 minus 4, 6 minus 5. Now, sometimes these are big numbers, and I think this one we can kind of do without the calculator, at least part of it. 6 times 3 times 2 times 1. Okay, so that's the square root of 36. So the area inside here is 6, this would say feet, 6 feet squared. So kind of a nifty little formula. I've always, before I saw this, I always wondered, how do you find the area if you just have the sides? I mean, we could use law of cosines and find an angle and then maybe get into the other formula we had. What was the other formula we had last time? Which to me is a little bit harder one to remember. If I can even find it. And 7.1, it was, the area is like equal to 1/2 BC sine A. We could use something like that, but, the problem with that is, you have to get the angle, you have to use law of cosines to find it. It'd be a lot of work. So this is a lot easier. So first you have to find this S by adding the sides, which is pretty easy. You just add them up, divide by 2. It's important that you divide by the 2. Then you take the square root of that. 6 minus angle A, the first, the second, the third, and then you got it. They have an example like this in the book, but these were very big numbers. So they used a half, the same thing as dividing by 2. They came up with this number right here. Then you can see that this was a pretty big number, so they had to subtract the sides from that number, and they took the square root of that whole thing, and then they came up with a thing. It says use a calculator, obviously. So that's Huron's formula. They showed how he derived it and stuff like that, but we're not going to go into all that. And there's different ways you can derive these formulas. Sometimes they use double angles, and pretty complicated how to derive this angle. Usually in higher math, sometimes you're taking a trig, sometimes you're taking a trig class for college, and sometimes you have to show on a quiz how to derive these things. But we're getting the easy course, okay? The abbreviated course. So I hope this helps. Right now, boom, I think I'm hitting my head on this. Just kidding. So anyhow, this is how you would do it. It's pretty neat. Transformula. So I hope this helped. Try some of these problems. And I think they're pretty straightforward. So let me get rid of this. Let's sign out of here.